Great. Well, Jakob, thanks for putting the first item on the agenda. So over to you.
Yeah, totally unprepared, but I thought I should give an update on the pack file cache project, because that's the main thing I've been working on together with Sean, who also gets other things done. And Sean was out for a week, then I was out for a week, so it may be less clear where we are now for everybody. So I thought I'd give an update. So the idea is to make git clone and git fetch faster by caching the large chunk of data that needs to be cooked on the server every time somebody clones something. And we now have an RPC in Gitly that allows us to observe this work happening. And this RPC would eventually have a cache sitting behind it, but right now it doesn't. But it's already very interesting because we can get log data from it. And this log data shows us computes the cache key, and it shows how many bytes are generated by the RPC. So just by looking at those logs, we can see how much data we will be storing, what the hit rate would be. We can think about what a good retention time is, or what the trade-off is between retention time and storage cost. And where we are now with that is that we have that on in production, and it's creating log data, and we can then fish that out of BigQuery and download the log data and do offline analyses, because I think in 4 hours we create about 1.5 million records. Well, the request rate is about 100 per second, and we thought that the 24-hour period is a good, like 24 hours on a weekday is probably going to give us a good insight of what goes on, because weekdays are busier than weekends, and there's definitely a 24-hour periodic nature in traffic. So if you have a 24-hour window, then you should see everything roughly that happens. So we're now busy capturing a full 24-hour period.
When does that 24-hour period end?
So our plan is to make it literally Thursday in UTC. So it would end at the end of today. But strictly speaking, it started somewhere yesterday. The thing is that the way we use
sorry to interrupt. The reason for asking was just that tomorrow is an unnaturally slower day for GitLab in general, being Friends and Family Day. So I'm glad to hear that the window is before that.
Yeah. Yes. Yeah. Exactly. And we have some flexibility because we started already on Wednesday afternoon. So if we find that there's a strange taper towards Family and Friends Day, we could even cut it a little earlier. It's just that, yeah, both Sean and I are not very comfortable working with BigQuery, and the best way we understand it right now is that you have to tell BigQuery to create a table per day. I think that might be because we store logs per day or something. So everything is much easier if we constrain ourselves to one calendar day. It's not that bad. Otherwise, we need to do the work twice, download 2 chunks of data and glue them together locally, which is not rocket science, but it's easier if it's one file. Hence one calendar day in I guess UTC.
The project's complicated enough without trying to figure that out as well. So that makes perfect sense.
Yeah. So and it's fun that we get to use BigQuery now, and well, Sean gets to use it, and I get to ask Sean help. How do I do that? And then Sean figures it out. But one of the things we also want to have as a result of this, we're doing this analysis on the log data, and we're trying to do it in a way where it's reproducible with a script, so that assuming that this all works out and this becomes a feature, we can put that script somewhere in the documentation. And if somebody else wants to roll out this feature on a self-managed instance, they would also have the option to analyze beforehand if it's worth it or what the impact would be. So that's also why it's good that we're not working in Kibana, because not everybody has Kibana. And the other reason is that the type of analysis we want to do, they are easy to express if you just have a script in a loop that looks at JSON objects, but they're hard to express as Kibana queries. So it's just easier to do it this way, and it's And I was going to say it was 100 requests per second. So we think that that is going to be about 10 million records or something. And a laptop can handle that. Like, it takes a moment, but it's doable. You don't need Hadoop or MapReduce or whatever in the cloud to analyze that. Yeah, so that's actually, so that's exciting. And I hope today to submit for review the sort of the core of the cache mechanism that I've written as library code for Gitly. So right now it doesn't get called yet, but it has tests that exercise, yeah, the interesting behavior. Web scale, yes. Uh, we're trying to keep it below web scale. And so, yeah, we're trying to get that into review already. Although there's a slight chance that the log analysis teaches us that we need to tweak things a little bit, or that we need to make some optimizations. But I'm hoping we won't have to. We'll see.
When Sean was enabling this stuff, I think, was it last week for the first time, and then he pulled back because there was a degradation in the Git apdex or something. Was that related or unrelated? I didn't follow the discussion to the end.
To our understanding, it's unrelated.
Hooray!
There is a noticeable impact of turning this thing on. And we were looking at the continuous profiler for the Gitly processes. And if you look at the heap allocation, so those are short-lived, those are allocations that happen during the profile, but that may not, that doesn't count whether they get, when they get removed again. And it looks like every byte that Gitly serves also gets allocated, which is not a great way of serving data, because usually you would have a buffer and copy something in, copy it into the network socket and reuse the buffer. So you only allocate that buffer once. And because of the way gRPC works and we structure this, it looks like every time we have a chunk of data we want to send from Gitly back to Workhorse or GitLab Shell, we allocate a buffer, put it in there, send it out, and garbage collect the buffer. So every byte has to be allocated and garbage collected. And you can clearly see this in the profiler, where the RPCs that do git clone create a ton of allocations. And so that's a big chunk of work. And we get a full copy of that chunk of work once this RPC is on, because it's doing the same, it has to send the same amount of data. Actually, there's a picture. Let me just quickly show the picture for that. If I can find it. That's what you get for not preparing this. Here we go. Wait, not this one, but was the last one. Yeah, these graphs don't show the memory increase that clearly yet, but because they were taken early. Yeah, this is the picture I was looking for. So these are all the allocations during 30 seconds, and this is an average where it's Gitly is allocating 1.5 gigabyte in 30 seconds in this particular window, or over these profiles. And the worst one, it was allocating 14 gigabytes in 30 seconds. It doesn't mean that it was using 14 gigabytes of memory at one time, but it was allocating that much worth of memory. And this part is sort of a given. So that's the workload created by Git HTTP and Git SSH. So on average across all these things, Git HTTP is bigger than Git SSH, but it will vary per server and per when you're looking. But so this is a big chunk of work, and there's an identically sized chunk of work that is all the new RPC. And there's one server, we still don't really understand why, but in the in the dashboards, in the saturation graphs, there's one graph that goes up for the memory. And no, I'm not going to, sorry, I need to stop sharing. I want to keep showing things and slow down more and more. I just need to say it in words. The memory, there's an aggregate memory graph that goes up in the saturation. And if you try to see why that is, there's about 60 servers, and it all seems to be because of one. And that's file
Canary
20.
file 01?
No, it's file 29. And I don't really understand what's special about that one. But when you turn the RPC up on, memory usage on that one sort of doubles. But we have plenty of headroom on the memory usage, so it's not we can get away with it. But yeah, and then looking at the profiler where there's this one outlier of 14 gigabytes or 15 gigabytes or whatever, you can't see in the profiler from what server that profile is, but I strongly suspect it's that one because the memory usage also went up there. But so it's noticeable when you turn it on, but it doesn't seem to be a problem. And the big question that we can't answer yet is how much of a benefit we see once the cache is in place, because the RPC that just measures things does not offer any benefit besides measuring things. So
but it does.
Go ahead.
It will tell you hit rate already, so you will have, like, we will know something out of this.
Yeah.
More than what data.
Yeah. We know the hit rate. What we don't know yet is, or what I find hard to predict. We know that creating these spec file responses uses a lot of CPU, and especially on Canary 01, where we have lots of CI, CPU usage on the GitLab server is dominated by the CPU calculating the same thing over and over again. So it's obvious that that chunk of CPU should shrink. But the reading from the cache causes I/O, and that means CPU time will be spent in I/O, and how
you
much
don't know
shift?
how that's going to calculate, like, in total, how much time we're going to save.
Yeah, what is the net
switching
effect
from I/O to from CPU
yeah.
to I/O?
I don't know what the net effect is for one, and the other question is that I have this ambitious goal of turning off the cache, the CI pre-clone cache on GitLab or GitLab. And so what happens now is that we download a chunk of like a stale clone from object storage. So that doesn't hit the GitLab server. The runner uncompresses that and then does a fetch on top of that. And these fetches are a small amount of data, but they still happen 200 times. So it's 200 times the same fetch. So once the cache is in place, those small fetches will collapse onto just one or two. And that's already good. But then if we stop downloading that data from object storage, we are generating it on the GitLab server. And what I'm hoping is that we can just get away with that and we don't need this cache anymore, because it is fragile and it is not a GitLab feature. It's hard for other people to use this cache. But again, what is the net effect? How does it add up in the end? That's an uncertainty. So I'm hoping we gain so much from the cache that we can turn off the other optimization and it will still be fine.
That's what I suspected from the beginning was your goal.
Yeah, it's just it's hard to.
Well, basically, you're kind of building the same thing, but into Git, so everyone can use it.
Into Gitly, yeah.
Gitly, sorry.
Yeah, but yeah, more or less. So that's yeah, that's where we are with that. We're learning from the analysis, we're gathering data, and we're submitting the next chunk of work of implementation for review.
What will definitely be worthwhile once that once the data collection is finished and once the analysis is done, then sort of publicizing what we think the impact is going to be, because there was a lot of interest from both the data stores team and we were working with GitLab on it as well. And I think once we can tell them what we think the impact will be, we should let them know, because that might help our MRs get through a bit faster as well, if they know how much this is going to improve the situation.
Yeah. Yes, yeah. One thing that I'm very particularly curious about that I did some preliminary, like we got a couple small chunks of data and I did some analysis on that. But I didn't take it very far yet. One thing I'm very curious about is the difference between Gitly servers. Because if you pull the data out of BigQuery, it's just everything. And you can do a global analysis, which can give you a ballpark of what to expect. But there's going to be a lot of variation from server to server. And I expect that the cache hit ratio will be much higher on Falcon Area 1 because of all the CI, and on other servers it will be kind of meh. And just to see in a picture like what that distribution looks like will be interesting.
I like that. It's a very technical term, meh. Thanks for showing us that and for the update there. It's I'm really looking forward to seeing the next step. Like I can't wait till the data's pulled. So is there anything else that anyone wants to go through or wants to show today?
I could perhaps show that we now have a stage group and stage mapping in Prometheus. I don't know how interesting that is, but Sean and me yesterday played with that to get a number of how many endpoints a group would own. Let me look that up.
Bob, if you're talking, you're muted.
So yeah, sorry, I was muted. So before we couldn't, we didn't have this information inside Prometheus. We only had feature categories, and these are the things. The feature categories are the things that we've defined as features that are owned by groups that are in stages, and we use features categories to tag things inside GitLab Rails, and we use feature categories so they don't change that often. So we tag workers and endpoints with that, and this shows how many endpoints a group owns. So we can see that, like, the results are not super surprising here. The oldest features have the most endpoints, the most used ones. Package has a lot because we think that because they support all the different kind of package managers and so on. So that's all different kind of endpoints. The fun part about this is that this is coming now all from Prometheus. So we don't need to know the list of feature categories that are owned by a group to be able to look for these. We just need to know the name of the stage group, or we can even do this by stage, I think.
So the metrics have stage groups on them. So whatever possible values for stage groups exist in the metrics are whatever stage groups are. Well,
so the metrics themselves, the interesting metrics are feature categories, but then we export this thing. It's called GitLab feature. This one here. If I copy this. And that's just a series it's a series for every feature category with a stage and a stage group on it. So we can join that to other things, and it's just a one all the time. That's something
where does it come from?
It comes from the stage, well, indirectly from the stages.yaml file in the GitLab website repository, the handbook.
So what exports this?
It's a recording rule. So Prometheus, I think, yeah, that's a thing that is
So
a little
it's
bit.
basically in the config file of a process that scrapes, and it creates this on the side.
Yes,
From the
so it
config
ends up in
file.
Thanos,
Yeah,
which is where we want it.
cool.
There's something, because here we can see which Prometheus is exporting it, and like that. Like that, as a side effect of that, it has a lot of labels that we're not interested in that we need to remove in every query. So I might look into that too. Like,
Well, if it's a recording rule, you might actually, I don't know how that works. Maybe you could say in the rule that you don't want to see those things. But
well, those maybe. I don't know either how exactly that works. Like we only need this. We only need the 3 labels on them, and we don't need, because this will effectively cause duplicates that we need to filter out.
And when does this read the website YAML? When does it get updated?
It gets updated when we run a script and something is going to shout at us by creating an issue if it becomes out of date.
Which is the same mechanism we have for checking that every feature category exists and has an owner.
Yes,
yeah,
it's all hooked into that.
Yeah, awesome.
So this is all pulling together towards having this information for the dashboards and the alerting.
The dashboards, the alerting, but it stems from our recent work on the error budgeting demo. So we need to be able, we need to be able to collect everything for a stage and for a stage group, but these labels are on several metrics.
Yeah, so this is the first step. But once you know how to do this, if we're pulling that YAML file from the handbook, we can probably also see what Slack channels belong to these stage groups.
Yes, that's all part of it, yes.
Yeah, so in the next step, we could extend the script so that it grabs Slack channels, and if it needs to, it can ping channels or create messages that reference the channel. So if somebody sees an alert, they know what channel to go to. So this.
Yeah, there's a discussion that I think Dylan, the search group raised it, the global search group, that suddenly like Elasticsearch wasn't processing any new things anymore, and nobody knew because we don't have alerts for those queues because they're throttled. Like we expect there to be buildup of work to be done, but we don't want to overload Elasticsearch. So like, but in this case, nothing was being processed, and because it's using our general alerting rules, we didn't notice. Yeah. So that's probably the first thing that we're going to have like a routed alert for, so the global search team can keep an eye on this, like without us intervening, because they play around with Elasticsearch itself and so on. Yeah.
It's been nice to see the engagement from everyone between the dashboards, this alerting piece. Everyone seems to be interested in what we're doing with this, and it's just so nice to see what we're doing being used. And I was appreciative for Huang Min putting in that link to an OKR, that source code has now an OKR linking to how to regularly review the dashboard. So it's just nice to see what we're doing is of interest to people and being used.
Yeah, the thing that keeps coming up is alerts, and it's not something we've thought about before.
Well, we've thought about it in the sense that it's been an issue on the backlog for ages. But
yes,
we haven't.
That's for alerts that
it.
we know. That's for the alerts that we've defined. Now the stage groups are coming to us like, this is something we need to alert on, and it's not like a service level indicator that we use to look at overall health. They're
I see what you're saying.
more at them.
They want to have custom alerts, and they don't know how to make them. And so then the question is, who's best placed to help them? Can we help them?
Yeah, we can. What can't we do?
What do they? I guess the question is, what do they need to be able to make these things themselves?
Well, I think the dashboards were a good place to start, and I think that's what triggered it, because now they put lines on a dashboard and they put red lines on a dashboard, and they want to get an alert when the blue line goes below a red line, for example.
I suppose what we're doing here is that we're we're pulling them into committing to the runbooks repo, and that's also where the alerts are. And they're now in the directory where they're defining their own dashboard, and we need to somehow make it easier, or the goal is that they can also do things in the other directories where the alerts are. And I don't want to make it sound like they should know how to do that, because I don't know how to do that either. I find the runbook scary, repo scary, and it's sort of a jungle myself. But yeah,
I think that's all we can do is get them towards being comfortable with it. And I think you're right, the dashboards were the right first step, because it was this gentle introduction into this is what the production systems look like when they're running. And yeah, I think a next step, a natural consequence of this is having them be more involved in what we're doing. So I think we'll get there. This is the start of quite a long engagement, I think, with all of these groups.
One thing that I was thinking about, like yesterday on the bicycle, was we could start. I'm going to run this by Andrew once he gets back, because he's like he has like a goal for this and just not enough hands to type it. But what I was wondering about was maybe we could start building like a group catalog, like we have a service catalog and a metrics catalog, and then define, like have a way for groups to define group level indicators like we have service level indicators. So that would be like an automated way for the, an easier way for them to define alerts without having to actually define alerts that way. When they add an indicator, like a group level indicator like that, to their group definition, it will automatically be on their dashboard, and it will automatically have alerts and all of that kind of stuff.
It's an interesting idea. I'm keen to see what Andrew's thoughts are about that, and if it matches up to what he's been thinking about.
Yeah, that makes a lot of sense, because I'm still not quite used to this, but I think this is what Andrew has been building with all this JSONet code, is this idea of declaratively saying what should be out there and having as much as possible be auto-generated. So if we can have a declarative syntax for where a group can say, I'm interested in this metric doing that, and then the whole thing just rolls out, that would be one way to help them get the information they need.
Yeah, like right now we're kind of telling them what is interesting generally, and then removing what is not for them. But this would allow them to pick what is interesting for themselves. There's always the problem of what is already available in metrics as well. Yeah.
Yeah, but it might be very interesting to work with source code if they're the ones interested in having interesting custom metrics, because working with them would teach us what sort of things are useful, or what those metrics should be. One thing I'm wondering is, do people want what sort of alerts do people want? Because they probably don't want their developers on pager duty. So do they want Slack pings? Do they want issues? Do we have a nice way to say, if this happens, open an issue?
I only briefly looked at the code. That's all going through, what is it, the pager service thing. We have ways of routing alerts differently,
Yeah.
but Slack is like the main thing, and yeah. Kind of.
I suppose we already have that better.
I think starting with Slack makes sense, because it's the more immediate form of communication than an issue. Also, if we get into a stage where we're just creating tens and tens of issues for a stage group, we're just like throwing it in a hole. Whereas I think if you're constantly sending things at Slack, at least you aren't destroying their backlog while we automatically create issues for over the weekend.
You don't ruin their issues, but what I've seen with these alert channels is that they just get flooded with alerts, and I lose track, or it becomes a memory hole.
I mean, it's the same problem as what the SREs find in infrastructure, right? Like, you don't want the alerts to be noisy. They need to be actionable things. And if you suddenly start pumping noise at people, they just drown it out. They just block it out. So we just have to be careful about what we choose to alert on, and also advising the groups themselves that they don't need to see noise. because they might come to us and say, I want to know every single time this line drops below that line. It's like, you don't actually want to know that. You want to know when it's been down for this length of time, or these other things match up. Like, we need to discourage them from wanting to see noise.
But that's the interesting but hard part about that, because some of those metrics, like the thing that Kegos was working on with CI trace conflicts that discovered the problem that I won't mention on a public thing. Like that was as soon as this was above a very low number that we in infrastructure wouldn't really look at as something to worry about.
But that is not the same thing as having a noisy alert. It could be that if you're a stage group and you know, like, this feature is being used in this way, that this number should never drop below X for more than Y time. And that would make sense from the point of view of owning the feature, and not making sense of from the point of view of making sure all the servers are running well and humming along.
It's a little bit, well, difference between the view of the startups and the view of the SE. When I talk to some startups, especially code review and support, they mention that they don't care about the real-time metrics. Not actually don't care, but they will care more about the metrics over a really long period, like 1 month or 2 months, because typically when they perform some kind of optimization or some feature, it would take them about 1 month for the whole optimization to be effective. So they really want to compare the current, like after the deployment by 1 month and the about 2 or 3 months before, to compare the performance of the optimization. So their viewpoint is a little bit different. And even though that we can push the alert to them, I really highly doubt that what they can do to resolve the situation. Yeah, because most of the time is that they can't do anything. This is the diagnosis. They have to take some time to investigate, some time to implement the long-term solution, and then some really long time to make things go into direction. So I'm not really sure whether we should focus on the alerts or not. Maybe we should focus on the collect what metrics they need the most in the right now or in the future. And when we have all the data and they can just live and use our dashboard daily, then we can come up with the alert.
Yeah, the thing is, what if you have good dashboards, and if you can fake having an alert by just looking at the dashboard regularly. And maybe for these long-term things, that is the right thing to do, because it's hard to define an alerting rule that would spot something that as a human you can see when you look at this dashboard. So maybe we shouldn't get too distracted by the alerting part, and well, we shouldn't get so distracted by the alerting part we forget that everybody needs to have a dashboard.
Yeah.
Yeah.
So
the two examples are actually of people who already know the metrics, like they know what they're looking at on the dashboard, and they don't want to go there to see if it's wrong. So like that was the search group and the continuous integration group.
And in terms of observing metrics and using these things, those teams are more advanced than some others who don't even know that the dashboards exist right now. And I think because each of the different teams is at a different level of maturity, we'll have to think about how is best to engage with each of them to actually get them to the next step. And someone like Gregor, they're so much further along. So we have to almost be in a different phase when we're working with them. But I think the key thing is to just keep the engagement with the teams up, because I think the worst thing that could happen is we've produced all of these things, people come to us and they're super interested, and then we just say, no, we'll get to that in 6 months' time. Like, I think we're going to have to be flexible with treating different teams in different stages, because that's where they're at. But that's hard because it's not like straightforward saying, right, we're in this phase of the project, now we're in that phase of the project. I think it's going to be a little bit more messy than that.
Yeah. But overall, it's exciting because maybe I'm misremembering, but I feel like this has been in our team mission statement for a long time now, that we want to help stage groups understand how their stuff operates in production. And we're now at the point where we're actually engaging and becoming that bridge, or that link between
it's
them
pretty much
and
something
their data.
it's pretty much something I've been saying since I joined the team, was that we could be this bridge. And as soon as these engagement epics started, I closed down a whole bunch of other ones that I raised when I joined. So for me, this is super, this is really fantastic to see this. And I think this is a really effective way of almost scaling the infrastructure team in a sense, because we're outsourcing looking at some of the problems back to the teams who own the code. And as I might take this on a bit of a diversion, I've been involved in this conversation about infra-dev issues. And as part of being involved in that conversation, I've been looking at actual data. So are there really more infra-dev issues than there used to be? Are they being closed at the same rate or not? And why? And what I can clearly see in the data is that since that massive hiring spurt in 2019, the MR rate has shot up. And at the same time, we've increased how fast we get things to production. So naturally, there's going to be more incidents that come out of that, because there's more change and we get the change there faster. But we're not doing enough on the other side of dealing with that. The infrastructure team is it's only a slightly bit bigger than it used to be. And the most effective way, I think, to encourage people to be aware of what they're doing is to give them the visibility for that. So this is all coming full circle for me. It's all coming together really nicely from my perspective, and I'm very excited if you haven't noticed.
I'm happy you mentioned that, because one thing that I keep wondering about is how the error budgets fit in. I know we are talking about that, and that's something we want to work towards, but I don't know when and how. Well, I kind of know how. I know what needs to be done, but I don't know where it fits in.
Well, Maren, I'm hoping I'm remembering this correctly, but Maren has started the conversations again with Christopher, and that's why why we asked you, Bob, and Andrew to have something demonstrable at the last SAS call. And I think that also with the just the increased awareness about the impact of incidents lately, I think that it's a good time to be having these conversations and to start to reintroduce it. But as to when we actually do the work to put these on the dashboards, I need to double check with Maren when is the right time for that. I mean, I didn't want to wait to release the dashboards until we had error budgets, because, in the spirit of iteration, we could have been waiting months for that. And I think going back to the stage groups again, saying, right, well, we've added these things to your dashboards and this is how they work. So short answer to the question is, it's coming. It's relatively soon. I need to double check with Maren for when we need to start pushing this out.
Because the issue 888, that is the main thing. It has a whole bunch of information that Andrew spewed out before he was going out, was taking time off. That's going to be the start of that's going to spin off in a bunch of issues, I think.
Yeah, so that issue came about because we had a conversation about what needs to happen next to get to error budgets. And the statement was, oh, we're actually not that far, we just need to do X. So I said, no, well, write it down, because I'm concerned that it's not just X. So writing it down is produce this list of this is what needs to happen in order to get to the next step.
Yeah, the time consuming as in wall time, not people time, is the metrics need to be adjusted, and then I'm muted again. So the thing that's annoying, with all of with a lot of that work is that metrics need to change, and those metrics are used for alerts and graphs and all of that thing. So we need to do that carefully. Yeah, so that takes time.
So you mean for the literal enforcement of error budgets?
For just recording, basically.
Yeah.
The first thing is recording, but to be able to do that in a proper way, we need to tweak metrics to include feature categories and not explode cardinality. Like now we have some histograms that have 15 buckets or I don't know what, which yeah, we can't add a feature category label to those because then, well, Ben's not going to shout at me because he's gone, but yeah. Prometheus doesn't like it.
Well, it sounds like there's two main or major parallelizable things. One is to have the data for the error budgets, and the other is to have everybody looking at the data and having everybody engaged with these dashboards and knowing their way around, knowing that they're usable, and that like more mature groups can have custom alerts because they know that they need to look at those things. Because it doesn't make sense if we just show up and you say, well, now we can enforce error budgets, but you can't see what went wrong, or you don't know.
Causing the errors, yeah. Exactly. That's
then you just have a stick to whack people with, but we also need to enable people to do the right thing before, yeah. So that sounds like two parallel things.
Yep, and the thing that's what makes it hard, because we are using metrics that sometimes look quite nice now because they are granular and all of that, but we want to roll that up in a budget, and then like we need to make sure they're still correlatable.
Well, on that note, is there anything else to chat about today? Great. Well, thanks so much for the time. Hoping you all have a great Friends and Family Day tomorrow, and we'll catch up with you again next week. Bye.